In this video, we're going to look at mental calculations having to do with multiplication. So similar to with addition and subtraction, we have some overlap with the concepts with the mental calculations. So let's start with compatible numbers. So compatible numbers means we look for pairing up numbers. So we pair numbers that are easier to calculate. Easier to calculate. And when I'm referring to calculate, I'm talking about in our head, right? Without a calculator. Okay. Sorry, this word easier looks terrible. Let me fix it. Easier. There we go. To calculate. All right. So let's look at an example. Let's say we are given the multiplication 20 times 37 times 5. Okay. So according to order of operations, we should start with the parentheses and do 20 times 37. Okay. But 20 times 37 isn't as easy as if I notice the 5 and 20. Those are easier to multiply together. And I'm motivated to do that. Now, really quick, technically, I would need to use some number properties to actually do this. Technically, what I would first need to do is use the commutative property to swap the 37 and 20, and then the associative property to regroup the 20 and the 5 to actually multiply those together first. Okay, which is what I'm going to do. Multiply those together first, and that gives me 100. But honestly, you don't need to use the number properties like this in order to apply them to the problem. So I'm just going to jump in and go ahead and do 20 times 5, which is 100. And then 100 times 37 is 3,700. All right. So just so we're clear, this is just showing the number properties in action, but we won't need to do that work now that we understand the number properties and that they are at play. Okay. So let's look at 2 times 25 times 79 times 2. Okay. So actually 2 times 25, that's not too hard to do in our heads. That's going to be 50. But 50 times 79, not so easy. 50 times 2, though, that's easy. That's 100. And 100 times that 79 is 7,900. So I'm just trying to pair up the numbers that give me nice, easy things to work with. All right, so there's compatible numbers. Now they're going to keep popping up even to in what we're going to talk about today. But let's look at substitution for mental calculations. So we're talking about substituting in to make the mental calculations easier. Okay, let me give you an example. Let's say I want to, sorry, let me give myself a little bit of space because I'm going to actually input something here. So I'm going to put a little star there because I'm going to put something in here in just a second. Let's say I want to multiply 21 times 103. All right, so as is, I probably can't do that in my head. So I want to be smart and rewrite one of these numbers in a way that helps me do the mental calculation. So I see the number 103 and I think, okay, well, that's 100 plus 3. And here's what I notice about this. This is a distribution. And in fact, often what we use the substitution for mental calculations is to use the distributive property. Okay, so we're kind of trying to use this property to make our life easier. So according to the distributive property, we'll do 20 times 100 plus 20 times 3. Oh, sorry, that's supposed to be a 21. Haha, just kidding. Haha, and haha. Okay, so 21 times 100 is 2,100. And that's 21 times 3, which would be 63. So 2163. There we go. So when I can do it in my head, that's a pretty good sign. Because sometimes I stumble over mental calculations too. Or writing the problem wrong. All right. 45 times 98. That's a 4. It's kind of a sad looking 4. 45 times 98. Okay. So if I'm going to try to use the distributive property, and technically you could pick either number to do it. All right. but I am kind of trying to set it up in a way that is helping me kind of look at it through the traditional distributive way where we're going from left to right. 98 can be rewritten as a subtraction. 100 minus 2, because I'm motivated to use 100, right? 100 is so easy to work with. Okay, so if I distribute the 45, that gives me 45 times 100 plus 45 times 2. Oops. 45 times 100 is 4,500. 45 times 2 is 90. Oh, and I just realized I changed that to plus when it should have been a minus. Okay, and then let's see. 4,500 subtract 90 is almost 400 and sorry, 4,410. I am just struggling to write. I apologize. All right. Let's try one more. Let's say 25 times 99. And if you want to pause the video, try it yourself and see if you get the same thing as I do. Go for it. But I'm going to start by rewriting the 99 as 100 minus 1. And I'm going to get 25 times 100 minus 25 times 1. That's 2,500 minus 25, which will be 2,475. And there we go. Okay, those are the substitutions. Let's try equal products. So equal products uses products, actual factors, to make things work for us. So it's where we kind of move factors around. Let me kind of explain what I mean by factors. So here, actually, let me do it off to the side. So like if I ask, what are the factors of 10? The answer would be 5 and 2, because 5 times 2 is 10. Okay, so 5 and 2 are the factors. We talked about that actually in the last video. So let's say I'm telling you the statement that 6 times 4 is the same thing as 3 times 8. Well, I could make 6 times 4 look like 3 times 8 if I broke up 6 into its factors of 3 times 2, and then regrouped the 2 and the 4, and that would be 8. So 6 times 4 does equal 3 times 8. I can literally make it look like that using the number properties, okay, and moving the factors around. But here's where it's useful. It's useful to do multiplications that are kind of hard to do in our head right off the bat, like 4 times 4. I mean, you could probably figure it out if you thought really hard, but 7 times 2, right? 7 times 2 times 4. Okay, well, 7 times 8, I happen to know, that's 56. So that's a lot easier to do in my head than trying to figure out 14 times 4 and carrying the 1 and all that fun stuff. Okay, let's try 28 times 25. And maybe you want to pause the video, give it a shot, all right? But I'm going to start by rewriting 28 as 7 times 4. And there are other ways to do this. I just want you to be aware. I remember I had a student break 28 up as 2 times 14 and was able to work it out. Okay, so yeah, it's totally possible. All right. 7 times 4 isn't as useful to me as 4 times 25, which is 100, times 7. And there we go. 700. Okay. I did want to mention, if I had wanted to do it as 14 times 2, like if that's what I saw, instead of 7 times 4, 14 times 2, I could be like, okay, 2 times 25, that's 50. Oops, that's 50. And then I could say, okay, well, here, let me break 14 up even more into 7 times 2. There we go. That's 100 times 7. And then we can get to the same place. So you can break it up as many times as we need to make it work. And the idea is to let your brain kind of work quickly so that you can get through the mental calculations quickly. All right. Okay, so that's equal products. Now let's look at approximation. So we use approximation a lot in mental calculations. And we are kind of allowing ourselves the idea that we know it's not going to be perfect, so we're okay. One type of approximation is just rounding. So use rounding to approximate. Okay, here. Part A. All right, so let's say I want to do 28 times 63. It would be way easier if I rounded 28 to 30 and rounded 63 to 60. And 30 times 60, well, that's easy. That's 1800, right? 3 times 6, add the 2 zeros. Sweet. Let's try another one. Let's say we want to do 194 times 26. Okay. Well, it'd probably be easier to work with 194 if I thought of it as 200. And 26 is actually probably not too bad. I could probably just work with 26 because 26 times 2, that's not too terrible. All right. But if you wanted to, you could probably round it to 25 if that's a little bit easier for you. And that would give you, of course, 5,050 plus 2 zeros. Wow, that's a weird looking 5. Let me fix it. All right, a little bit better. Okay. Now let's say we use compatible numbers to approximate. So remember, when we're looking with compatible numbers, we're trying to pair things up that make our life easier, okay? So let's say I'm multiplying 2 times 117 times 49. All right. I see the 49 and I'm like, let's call that 50. And then I'm thinking, all right, 2 times 50, that would be easier to work with first. So 100 times 117 will be 11,700. So I only needed to round one number and that made my life much easier. All right. Let's do 34 times 46 times 3. So for this, I probably would go ahead and put the 46 up to 50. I feel like that's a reasonable one. I might even go ahead and just do the 34 to be 30. I don't think that's unreasonable either. Okay, so 30 times 50 is going to be 1,500. And 1,500, oops, sorry, times 3 is 4,500. And there we go. Okay, now front end approximation, of course, is when not that we're rounding really, it's that we force ourselves to use the first digit only for our rounding. Hopefully you remember discussing that previously. First digit only. Okay. So it kind of becomes straightforward if you're not really rounding the number. So like, for instance, if I wanted to do 43 times 72, wow, that's supposed to be a 7. 72, there you go. Okay, so front number only, so that's going to be 40 and 70, so 2,800. 61 times 874, front number only, so that's going to be 60 times 800. That's going to be 48,000, since we have 3 zeros there. All right, and there you go, front end approximation. Not too exciting. Okay, the last major topic. I alluded to it, but let's just kind of take a moment to discuss it if it's been a while. Wow. Order of operations. Order of operations. Okay. So PEMDAS is usually what most people remember about order of operations, the acronym PEMDAS. And maybe you even learned the little mnemonic or the little, is it mnemonic? I can't remember the fancy word for it, but the saying, please excuse my dear Aunt Sally. So that helps you remember the order. The problem with thinking of it like this, wow, I'm having such a hard time writing these letters for some reason. The problem with thinking of it like this is that it kind of makes it seem like the order is this, and it isn't quite true. The order is more like this: PEMDAS, where it's actually parentheses first. So this is parentheses. Exponents are second. Third is multiplying and dividing. Here, I'm going to abbreviate multiply / divide. Okay, but it's whichever one comes first, left to right. In fact, that's also for addition and subtraction, which is the next step. Oops, it's supposed to be a T. Add, subtract. Fourth step. And yeah, it's technically, there's supposed to be a C in there. Wow. It's technically they're equal. It's whichever one comes first, left to right. And that throws people all the time. If you have looked at any sort of social media that does these stupid calculations things, it's almost always having to do with order of operations and not taking into account that multiplying and dividing and adding and subtracting are equal in priority. It's whichever one comes first, left to right. So let me give an example of one that proves this point. So 10 divided by 2 times 5. Let me actually kind of clean that division symbol up. Okay. According to the order of operations, I don't do multiplying first. I do the division first because I have a dividing and a multiplying both, and they're equal in the priority. Therefore, it's whichever one comes first, left to right. So the division comes first, which means I do the division, which gives me 5, and then 5 times 5 is 25. Okay, let's just try another one. Let's see. How about, let's do 30 minus 10 parentheses 2, sorry, there we go, squared. The computer froze there for a second. Plus, I don't know, 4, something like that. Okay. Now, a lot of people would want to jump on that subtraction because 30 minus 10 is very easy to see. Like a 20 is much easier to see than a 30 minus 10, but it is the lowest priority. I have to start with the parentheses. I have to. And in the parentheses, I first start with the exponent. So 2 squared, that's 2 times 2, which is 4. And I just bring everything else down. Okay. Now, 4 plus 4, that's 8. And then this parentheses is going to turn into a times. In fact, they might even in the book, and forgive me that I didn't do it, they might even have the times symbol between them. They might even insert like a little times symbol in between these. Okay. Sorry that I did not include that. But the parentheses does mean multiplication. And therefore, if I want to go ahead and multiply 10 times 8, oops, sorry, let me get my pen back. There we go. 10 times 8 is 80. Oh, I just realized I did a negative number here. Sorry, we haven't talked about negatives. I apologize. That's negative 50. Okay, sorry about that. Now, don't worry about negatives. You won't be asked to do that. Maybe it'll be a plus instead of a minus like that. Okay. But yeah, you won't be asked to do negatives until we talk about that. So order of operations here. In fact, let's make it plus, plus, plus. It solves the problem right there. Okay. I'm sorry. I couldn't take it. So that's going to be 1100. There we go. Better. No negative. All right. Oh, I got to make the original one plus 2. Okay. There we go. See, that's what happens when I try to make it up on the fly here. Order of operations. Make sure you understand that the actual multiplying and dividing and the adding and subtracting, right? Their order is whichever one comes first, left to right.